Alright, we are going to look at maximizing um, assignment problem as well as unbalanced assignment problem. In the previous lesson, I introduced the idea of minimization using Hungarian algorithms, where you need to identify the n by n square matrix, followed by the row reduction, column reduction, and then cover as all the zeros with the least number of horizontal or vertical lines. Now, you will get an optimal solution if the number of lines equals to n. If not, you've got to look out the smallest uncovered entry, then subtract it from all uncovered entry, and add that number to the entries that are covered by 2 lines, and then repeat the step 4, which is drawing a few or the least number of horizontal or vertical lines to cover all the 0 entries. Once you have done that, if the lines equals to n, you have got a optimal solution. And I've shown you examples of this where you can find optimal solution by crossing out the zeros. Now, all the examples I showed you yesterday were all on minimization. We are going to look at maximizing now. So, practically every single step is the same except for one additional step. What you need to do after identifying the cost matrix is to note the largest number in the cost matrix and then subtract every number in the matrix from the largest number. Then you follow the minimization procedure. So it's important for you to know, in this case, you know that you got to locate the largest number and then subtract every number in the matrix from the largest number. That's the first step. Alright, let's have a look at this example. A factory owner wishes to maximize the output by assigning 4 different operators to 4 different machines. First thing you need to identify is the cost matrix, which is just basically convert this table to a 4x4 matrix. Alright, next, identify the largest number. What is the largest number? Here is 115. Alright, let's go to the next page. So from here, 115, what you need to do is take away 115 from every single element. So therefore, for example, this would be 115 minus 80. This number is 115 minus 90. You still have a 4x4 matrix. Alright? Then you can start your row reduction. Subtract the smallest number from the element of each row. And then your column reduction. Subtract the smallest number from each column. Once you've done the row and the column reduction, cover the 0 with minimum number of lines. So start off with a column with 4 zeros, then the row with 2 zeros, and then we can do the other 2. You now know that there will be optimal solution because 4 lines and it is a 4x4 matrix. So therefore, we can determine the optimum solution. Start from the row with 1 zeros. So it has to be the last row. And then looking up, we can therefore assign operator A to machine 2, operator B to machine 1, C to machine 4, and operator D to machine 3. And you can work out the maximum output. Alright, let's have a look at the next example. Now, I want you to try this, please. Just look at how you would do it. Of course, I've given you the matrix. From there, what can you do? What is the largest number? So the largest number in the matrix would be that 30. So subtract every single element from 30. And you still get a 4x4 matrix. So for example, this one will be 30 minus 18. And this will be 30 minus 20. And so on and so forth. From there, you need to do your row reduction. Find the smallest number. So this one, the smallest number is minus 3. That is 0, minus 5, and minus 4. Do your row reduction. And you've got that. Then let's do our column reduction. There's minus 0, minus 0, minus 0, and minus 2. So therefore, we have to operate on the last column. And we get 0, 12, 8, and 4. The rest, we don't have to do anything because the smallest number is 0. Cover all the zeros. Let's have a look. I'll start off with this line. And then the column with 2 zeros. And the row with 1 0. Of course, you can observe that that's only 3 lines. And we need a 4 by 4 matrix. And we need 4 lines. So let's have a look at what is the smallest number with the uncovered elements, which is 1. So we delete everything from 1 from everything which is uncovered, and then add 1 to the two uncovered to the two numbers which is covered by 2 lines. This is the operation, this is the matrix that we get. And now let's draw lines. 1, 2, 3, and does it work? Not really. What we need to do now again is find the smallest number. This time is 1. We subtract 1 from all this and add 1 to this 2, and therefore we now have this 4 by 4 matrix. Alright, let's see if we can get 4 lines. Cover 1, cover 2, 3, and 4. Yep, we've got 4 lines. Therefore, we've got the optimum solution. So let's start off with the smallest, the row with 1, 0, which is row B and C. Row 2 and 3, which is machine 2 and 3. And then let's have a look at the next machine, which is machine 4. And then the last one, finally, is machine 1. So what we can do is assign 1 to D, 2 to B, 3 to worker A, and 4 to worker 3. And you can work out the total number of units produced, which is the maximum. So it is a fairly straightforward. Once you know how to do your minimization, all you need to do is to add an extra step, which is locate the, for maximization, locate the largest number in the cost matrix and subtract every single element from that number. What about unbalanced assignment problem? This is the number of rows is not equal to the number of columns. So it could be 4 operators and 3 machines, or 3 contractors and 4 jobs. So you need to add a dummy row or a dummy column with all zeros. Now let's think about it. Let's say we've got 4 operators and 3 machines. We may have one number here, one number here, and here we have 3 machines only. So therefore we have to add in a row. So once we add in a row, you can see that because every single column has a 0, you don't actually have to do the row reduction. On the other hand, if we have this situation, if we have to add in a dummy row of a column, we don't have to do the row reduction because every single row has a 0. So I would just write down here to not need to do row reduction, while this one is do not need to do column reduction. Alright, then the rest follow the method of minimization or maximization. Let's start have a look at one example. The director of company decides he wants a representative from the company at each of the 3 international trade conferences that are coming up. The director wishes to send a different manager to each, chosen from the 4 managers the company has based at its various branches, making the selection on the basis of the arrangement that keeps travel cost to a minimum. So we are looking at travel cost to a minimum. So the associate travels costs are as follow. Alright, what should the allocation of the manager be? So we now know we've got 4 managers and only 3 conferences. So therefore, what we need to do is put in a dummy conference. Alright, we would have a cost matrix which looks like this. So you got a dummy as a column. So from there, what you do is, you don't actually have to do the row reduction now, as I say, because every single row has a 0. So let's start off by doing column reduction. Once we've done the column reduction, let's have a look at this. The smallest number is 1040. So let's do column reduction, which means taking away taking away 1040, taking away 560, and taking away 1215. And from there, we got the next matrix, the 4x4 matrix, after the column reduction. And let's draw the line. First, we can cover the 4 zeros and then 1, 1, 1. So you can see that we actually have 4 lines and a 4x4 matrix. Then we can actually look at optimizing. So here, 0, 0, 0, and 0. So therefore, manager 3 does not get to go anywhere. Manager 1 will go to conference 1, which is this one. Manager 2 will go to conference 2. Manager D will go to conference 3. Alright, so therefore you can work out the cost. The cost will then be 1040 plus 560 plus 1215. So this is how you work on that. These sort of problems. Adding a dummy column. Let's try this problem. We now have 4 contractors, and then you've got 3 roads. So you need to do some road repairs. You need to think about minimum cost. So in this case, what I would do is add in a dummy road 4. Alright, so we have the cost matrix. So this is the dummy, this would be the dummy row. So because it is a dummy row, we don't actually have to do because there's all 0, we don't need to do a column reduction, we need to do the row reduction. So row reduction, that would be take away 16, take away 20, take away 14. And this is a resulting matrix. Let's draw the lines. We've got 3 lines and we've got 4x4 matrix. So not quite, we need to do the next step, which is finding the smallest number and then subtracting all this from the smallest number and add 1 into this two number here, or 2 elements here. So therefore we've got another matrix, 4x4 matrix. Let's start covering the circle again. This time we've got 4 lines and it's a 4x4 matrix. Therefore we can start thinking about assigning contractors to repairing the road. Start off with, of course, the smallest, the row with the ones 1 0, which means this one and this one first, followed by this and this. Therefore you can see that contractor A, contractor C, and contractor D gets the job. Alright, let's highlight it. Contractor A, Contractor B did not get anything. Contractor C get this. And contractor D get this one. Alright, so assigning road 1 to contractor D, road 2 to contractor C, and road 3 to contractor A, and you can work out the cost to repair the 3 roads. Alright, this actually is the last lesson on assignment problem, and hopefully you should be able to solve maximizing assignment and balancing assignment problem, unbalanced problems using Hungarian algorithm.